In this programming tutorial, I'll show you how to solve the Leetcode problem, fruit into baskets. It's a medium difficulty problem that often appears in Amazon's and Google's coding interviews. This time, I'll skip the brute force solution, and we'll go right for a conceptual overview of the optimal algorithm, its runtime and memory complexity, and coding implementation in JavaScript and Python. The task description goes like this. You are visiting a farm that has a single row of fruit trees arranged from left to right. The trees are represented by an integer array fruits, where fruits I is the type of fruit the ith tree produces. You want to collect as much fruit as possible. However, the owner has some strict rules that you must follow. You can only have 2 baskets, and each basket can hold a single type of fruit. There is no limit on the amount of fruit each basket can hold. Starting from any tree of your choice, you must pick exactly 1 fruit from every tree, including the start tree, while moving to the right. The picked fruits must fit in one of your baskets. Once you reach a tree with fruit that cannot fit your baskets, you must stop. Given the integer array fruits, return the maximum number of fruits you can pick. Now let's highlight the key points of the task description. So we're given an integer array fruits that will be something like 1, 2, 3, 2, 2, 1. Something like this. And our goal is to return the maximum number of fruits we can pick. So the maximum number of fruits. Given this array, we need to return some max. It's very important that we can choose any starting point. So starting from any tree of your choice. And we have 2 baskets where each basket can hold only a single type of fruit. So moving away from the metaphorical level, this means that we need to return the length of the longest consecutive subarray of fruits that consists of not more than 2 distinct elements. For example, the subarray 1, 2, and 3 would not be valid because it consists of 3 distinct elements, while the subarray 2, 3, 2, 2, 1 would be perfectly valid. No, actually not 2, 3, 2, 2, 1. 2, 3, 2, 2, 2 would be perfectly valid because it consists of 2 distinct elements. The optimal algorithm for this task is called a sliding window. We start from the first element of the array, and we move towards the end of the array. So in the first iteration, the sliding window includes just 1 element. On the second iteration, it includes 2 elements. On the third iteration, it would have included 3 elements, but the addition of the third element breaks the essential condition that says each basket can only hold a single type of fruit. So in this case, we don't expand the sliding window. We just move it. Moving on to the next element, we can expand the sliding window because we would still remain with 2 types of fruit, this time 2 and 3. Moving on, we can still expand it to 2, 3, 2, and 2. And in the last iteration happens the same thing as in the third one. We try to expand the sliding window to 2, 3, 2, 2, 1, but we can't do that. So we try to move the sliding window. Now here are some valid variants to pick up fruits, like this one, and this one, and this one, and this one, and this one, but not this last one, because it contains 3 types of fruit. The longest valid sliding window happens to be this one, 2, 3, 2, 2. So its length is our answer, which is 4. To implement such an algorithm with code, you need 3 key elements. The first one is a map to keep track of the fruits we've picked this far. The second one is the left pointer, and the third one is the right pointer. The right pointer increases on every iteration, and the left pointer changes only when we need to move the sliding window. We're going to visit each tree only once, so the runtime complexity would be linear at O(n), and the memory complexity is also linear at O(n) because we're using a map to store the foods we've picked this far. Now let's move on to the coding implementation in JavaScript. Start by defining two pointers. Let left equals 0 and let right equals 0, and the map, which we'll call storage. A new map. So we're iterating while the right pointer is less than the length of the array fruits. And the first thing we do, we add the current array element to the map, saying storage set foods right, and we increase this value by 1. Before we increase it by 1, we need to get it. We need to safely get it. So we say storage.get fruits.write. Let me get more space by maximizing. So fruits right or 0 plus 1. And we don't actually need the parentheses here. We put the fruit into the storage. And then if storage size happens to be greater than 2 at this point, we understand that we need to move the sliding window. So we reduce the count of the leftmost fruit in the storage by doing storage set fruits left storage get fruits left -1, and we want to completely remove the key if we got all the way to 0. So if storage.get fruits left equals 0, we're completely removing the key. Storage.delete fruits left. It is important because otherwise this solution, this condition will not make sense. Whenever we get to 0 here, we need to always remove the key so that the storage size reflects the number of fruit trees that we have in our sliding window. And eventually we advance the left pointer with left ++. And in every iteration of the loop, we advance the right pointer. Our result will always be the difference between the right pointer and the left. We don't need to keep track of the max in any other way. We don't need a separate max variable because we only grow the sliding window when the storage size is 2 or less. Otherwise, we're moving it. We're moving it by increasing the left pointer, and we grow it by increasing the right pointer without increasing the left one. So we can return right minus left. Let's run the code to verify it. Let's see. Okay, I messed up the implementation. So what's wrong here? Okay, looks like I messed up with parentheses here. It should be fruits get fruits.right or 0, then another parenthesis here. So what we're doing here, we are getting the fruits right, and if it's undefined, we'll replace it by 0. Let's try to rerun the code. Wrong answers here. Rerun. And another parenthesis issue here. We're getting, of course, storage get fruits left -1. So this parenthesis was misplaced here. Let's try to rerun the code. And now we got it. Let's submit the code to see whether it passes all of the tests. The submission was accepted. Our solution beats 78% of users with JavaScript. So now we can move to Python implementation. Choose Python 3 here, and let's implement the solution in Python. Start by defining the pointers left and right. Let's call them L and R in Python instead of left and right like we did in JS. initial equal to 0. Storage will be a dictionary. And the while right pointer is less than the length of fruits, we put the fruit into storage, saying storage of fruits are equals storage get fruits are or 0 plus 1. Then if the length of storage is greater than 2, we need to move the sliding window. So basket of fruits left, sorry, not basket, storage, of course, equals storage of fruits left minus 1. And now if we happen to get to 0, we need to delete this key from the dictionary. If basket storage, I keep thinking of baskets in this task, fruits left equals 0, remove it from storage. Storage.pop fruits left. Move the left pointer inside of this if branch and move the right pointer with art plus equals 1 at the end of the loop. And eventually return right minus left. Let's run the code. Oops, name left is not defined. Of course, it should be just L here. Rerun. It was accepted. Time to submit. The submission was accepted and it beats 83% of users with Python 3. That's it for today. Let me know in the comments if you have any questions about the coding task fruit into baskets or the sliding window algorithm in general. Cheers!